Hi, I'm Nur Fatina Amal binti Chab Azahar. So my matrix ID will be 2018657 Nice to meet you.
Hi, and I'm Muhammad Aidi Rafizi Wisni from HAT team.
Hello, my name is Haris bin Amirus. Now I will introduce about the downhole separator technology as our topic for our group. In the later stage of oil and gas production development, a large amount of water stream will be brought up to the surface alongside oil and gas. In the mature oil and gas development, 90% and above of water cut can be achieved. Okay, generally we know that in oil and gas development process, it's not only the hydrocarbon will be brought up to the surface. It's also a problem that all the water, not all the water, but some of the water is also part of the stream that will brought up to the surface. Okay. In addition of the natural component of the natural water drive, the produced water stream also containing groundwater or seawater and other miscellaneous organic or inorganic solids that will be injected to the formation to maintain the reservoir pressure. The produced water is also more saline than seawater due to the addition of chemical additive and can cause additional costs to transfer, to treat, and to separating the produced water before disposing it. Hence, improper handling of produced water can cause a severe pollution towards the environment. Downhole separator technology provides a solution in reducing the cost of production by reducing the needs to treat the produced water. Hence, the produced water will be injected to the reservoir while oil and gas can successfully produce to the surface.
So there are two types of downhole separator, which is known as DOSE and DGWS. So DOSE stands for downhole oil water separator. It is installed at the bottom well and separate the oil and water at the bottom. So there are two primary components here, which includes hydroclones and gravity settler. So hydroclones is used for bigger and more complex molecules or properties, and while the gravity settler is used within the well bore. So now let's go to the mechanism and completion design of a downhole separator. So basically we know that the design go hand in hand with the function or more likely mechanism to meet the purpose. So the well needs to be raised synthetically and be lifted up with artificial lift. So this is to improve efficiency of the production and also to maximize the production of oil. So moving on to the second row, which is DGWS. So the output and injection separated, they are used specker, and then the main equipment used in the mechanism is the cavity nozzles, which will pump the water forced out of the tubing, and water injection also is through gravity. So now we are moving on to the completion design of downhole oil water separator. So in this completion design, we must follow or accomplish by the points I showed in the slide, such as the first one is to separate oil from the water. Second, to make sure it provides energy for the disposal of water, and also to make sure all flow to the surface. And the third one, to provide zone isolation for water injection. A packer is also used to and installed to provide isolation zone from injection to production, and a second packer is also used to ensure or to make sure the fluid go through in separating assembly, not through using nozzles. As for the completion design of a downhole gas water separator, it uses mud anchor with thin walls which increase the size of the separator annular area. And secondly, it uses a low viscosity fluid application, which is for the gravity driven separator. And then the separator will occur when the superficial downward liquid velocity inside the separator is 6 inch per second. And the third one is the annular area between the casing and separator should be large enough. And the fourth one, the multiple rows of opening are not necessary, as the part plugging is anticipated based on the chemical evaluated on the fluids.
Okay, next, I will continue with the advantages and the problem of downhole separator technology. Okay, for the advantage of downhole separator and what it brings to the table. First, as in the introduction, as I said, downhole separator technology will reduce the total cost of production of oil and gas. Downhole separator technology reduced more than 70% of the water that was supposed to be produced, thereby reducing the total cost of lifting, treating, re-injecting, and disposing of produced water. This will be greatly impacted by how the engineer will carry out their production without worrying the water that must be treated. Hence, they will be reusing the water to re-inject in the formation. By doing so, the cost of production of oil is greatly reduced. Okay, based on the image on the side, downhole separator installation reduces the production of excessive water. Second, prevention of pollution. Downhole separator technology can cause reduction of environmental impact of oil and gas operation. Standard injection well operation pose a significant but manageable risk of environmental pollution. The highest risks occur due to surface spill during re-injection of the separated brine. By reducing the produced water that will be brought up to the surface, hence there will no spill or less spill. By reducing the amount of brine brought up to the surface and re-injection occur, the environmental risk associated with re-injection wells can be reduced. Okay, 3. USDW protection. What is USDW? USDW stands for underground source of drinking water. Pollution of underground source of drinking water. Produced water in most cases contain brines. With downhole separator technology implementation, the engineers can protect the aquifer in the formation that can be used in the future as underground sources of drinking water. With the downhole oil water separator technology, dissolved impurities are not allowed to get to the surface, hence they do not pass through interval containing underground sources of drinking water. Also, since the water does not require the injection from the surface, it will not pass the aquifer. Okay, for the fourth advantages of downhole separator, because downhole Oil-water separator technology uses underground equipment, surface brine disposal operation, which is produced water disposal operation, which may involve pumps, pipes, tank batteries, and other storage facility, also can be reduced, hence minimizing the facility size and causing the additional cost of facility can be reduced. And lastly, the downhole oil water separator system is used for reinjection, thereby increasing the drawdown pressure in the formation, which can result in increased production rate for the oil and gas production system. Okay, not all technology have all the advantages. There is also a problem with downhole separator. Mostly the problem occur for the downhole separator technology from the machinery of the technology, and also the problem come from the formation. Okay, the first problem that comes with the downhole separator technology is injectivity decline. In order for the downhole separator technology to function properly, the injection zone, which is the formation, must have sufficient permeability and porosity to accept brine at pressure within the capability of the pump. Inappropriate fluid contacted sensitive sign can damage the part of the permeability. As the graph on the beside, as we can see, the injectivity decline will increase if the pore volume injected is decreased. Particles in the produced water clog the injection zone. In fact, injectivity decline caused by the various contaminants in the water phase widely exists in water flooding operation. When the injection operation occurs, it's not only water that will go in the stream. There's also containing the sediments, the participation of chemical additive. This phenomenon is referred to formation damage, which can lead to serious loss in productivity or injectivity. It is a problem also to feed the separator inside the well, because the equipment in particular must be fit to channel to bypass oil flow around the pump, and motor assembly must be fitted into a very small cross section and are exposed to very high flow rates from the production process. This can create a risk of erosion or corrosion for the equipment. Okay, the second problem that comes from the downhole separator technology is solid plugging. Excessive sand not only damage the injection zone, as the previous point, they also result in premature mechanical failure of the separator pumps or bypass tubing. Okay, as the diagram below shows that depletion increases effective stress. High velocity of viscous fluid can move sand. Hence, when the sand moves in the formation, it can cause damage to the equipment. Okay, in at least 2 cases, solid production was so excessive that the entire pump or separator assembly was packed with solid when inspected at the surface. When the produced water go into the stream, they also will bring any sands or rock that can cause damage. In one case, also the solids were formation solids, and in the second case, the solid were iron sulfide scale, which is the additional chemical additive. Okay, next problem that come from the downhole separator technology To protect the producing reservoir, the injection zone must be adequately isolated by an integral confining zone and sound cement behind production casing to prevent the formation from collapsing or from damaging the equipment. If isolation is not sufficient, the separated water can migrate into the producing zone and then short circuit into the producing perforation. This can create problem as we want to produce pure oil without any addition with water that can cause problem when we treat and producing the oil and gas. The result will be recycling of produced water with oil production rates dropping to nearly zero because the water will overly.
Limitation of downhole separator. First, wellbore is a very limited space. Second, the engine has to be installed below the production area to enable it to be used. The third, the system works better in carbonates compared to sandstone formation. Fourth, due to plugging inside the system, reservoir that have a sand production may not be suitable for this system. The fifth limitation of downhole separator is system can be used to wells producing high volume of water oil ratio. 6. Oil density must be higher than 986 kg per 12 degree API. 7. Minimum difference of specific gravity between oil and water should be 0.05. 8. Cannot be stimulated in the areas below the pump without pulling. 9. And the last one, it is preferable not to apply this technology to deviates well, especially those without residual saturation of oil. Okay, so for the conclusion, the downhole separation technology allows for the separation of oil, water, and gas in the downhole. It can reduce water production and save energy by moving the produced water to the surface. So the downhole separation technology is theoretically feasible but technically immature. Industry adoption of the downhole separation technology because of poor efficiency was stagnant. As a result, most service providers' method for hole separation has been discarded, so there's no longer in use of this technology, and declining injectivity of separated water in the most recognized problem from the previous application. With that, thank you.